Now, what I have on the screen right now is something that I've referred to over the years as my one-page cheat sheet to everything that you would need to know about the OSI model. And it really kind of is, all right? I mean, this is something that I created, it's probably, it's over a decade ago, and I haven't changed it. Okay? It's still the same model, and it's still the same basic information you need to know about it in order to be successful in computer networking. Now, if you get real deep into computer networking, and more specifically, if you want to be a network component developer, then you're going to need to know more than just what I have on the screen. But if you want to get your career started, this is all you need to know. And to take it a step further, where this really came from was way back when I was teaching a course called Networking Essentials, which was tied to an exam called Networking Essentials. This covered everything that you would possibly see on the exam, and I would say that that is still true today. Now let me explain piece by piece how we get to what you're looking at on the screen. Okay, first, you have to know the layers. Okay, and you have to know them in the right order. That's something I didn't mention. You have to know not just application, presentation, session, transport, network, data link, and physical, but you have to know them in that order, and you have to know that the application layer is on top and the physical layer is on the bottom. Okay, that is significant. You'll see as we go through this the significance of having layers in one place versus another. The next thing that we need to know about these 7 layers is what happens at each of these layers. What's the purpose of each layer? And I'm going to tell you, before I even start to explain the words that I have listed next to each of these layers, I'm going to tell you there's a lot of gray area here. Okay? You can read all kinds of different books, and each one will have a slightly different definition of the purpose of each layer. And what I've done here is I've created just a quick 1 or 2 word definition to just generically give you a rough idea of what's going on in each layer. Because I'm not real concerned with you having an absolute, hard, fast, defined knowledge. I just want you to have a general understanding here. So starting at the top, the application layer. The application layer deals with network APIs. API stands for Application Programming Interface. And what it means is it's an interface pretty much between the application running on a computer and the networking components. Okay, it's an interface between the operating system and a network, or an application and the network. And when we put the rest of this OSI model together, you'll understand why that function is at the top of the OSI model. The next layer down is the presentation layer, and I simply have the word formatting. This is where it is determined the format that the data is going to be transmitted in. The session layer deals with synchronization. And again, a lot of this is going to make a lot more sense once you see how the whole thing works when you have computers trying to talk to each other. But synchronization of communication takes place at the session layer. Transport layer, the word I have there is packets, or what I sometimes write is packet management. When data is transmitted out on a network, right? When you take a file and you transfer it from one computer to another, it's broken into much smaller pieces, and those pieces are referred to as packets. And packet management takes place at the transport layer. The network layer deals with addressing and or routing, and this is something that you're going to learn in more detail in other lessons in this course as far as IP addressing and routing. Those are actually 2 other lessons, so you'll get a full understanding of that. The data link layer deals with something called data frames, or what I've written in the past sometimes is data frame management. A data frame, if you were to look up the definition, you would find that very often it's considered to be synonymous with the term packet. So that's confusing. If the transport layer is packet management and the data link layer is data frame management, well, that seems kind of weird, right? Same thing going on in 2 different places. The difference is that at the data link layer, what we're doing is we are packaging the data into a frame that is appropriate to go out onto the network. So it's almost kind of like at the transport layer, we're dealing with the management of the little pieces of information, and it's at the data link layer, we take those pieces of information and put it in the right size, or we take that piece, right, because we're talking about one piece of information at a time, and put it into the right-sized envelope. And that's why, although both a data frame is like a packet of information sent out on a network and a packet is a packet of information on a network, that's kind of the difference here. And the last layer says hardware. The physical layer just deals with hardware. How is the computer actually attached to the network? Now, I don't want you to get real caught up with this yet. Okay, I want you just to kind of listen to what I'm saying. Those are some real generic definitions, a lot of gray area here. Let it be that way. Because what I want to do next is talk about how data travels through the OSI model. And before we even talk about that, I need to explain that this is not literal. Okay, there's not literally 7 layers. You know, if you open up your computer and you look inside, you look at a network card, you're not going to see a chip for every one of these layers. There's nothing physical, nothing tangible that you can grab onto here. Okay, so this is kind of a concept of how data travels through the OSI model. What I've done to my diagram here, I've created a second OSI model. I've put computers up at the top of the OSI model, and I've attached a network cable to the bottom of the OSI model. And the reason I did this is because I want to illustrate, you know, if we have 2 computers on a network talking, this is how data travels. When data leaves the sending computer, it has that application programming interface to the network. That's where it all starts, saying, hey, I've got something for the network. And it enters into the OSI model. Then that information is passed down to the presentation layer, who determines the formatting and sends it down to the session layer, puts on synchronization information, passes it down to transport, down to the network layer, down to the data link layer, and finally down to the physical layer, where it is then placed out onto the network cable, where it goes across, gets to the receiving computer, and then it goes up through the OSI model. Okay, so it's important that you understand that on the sending computer, data travels down through the OSI model, and on the receiving computer, it goes up through the OSI model. And the one other thing that I've drawn on this diagram is you'll notice that there's these little dashed lines that go between the application layer and on one computer and the application layer on the other, and the presentation layer on the one computer and presentation on the other computer. Matter of fact, it does it for each of the 7 layers. Those dotted lines represent theoretical communication, meaning even though data is passed down through the OSI model on the sending side and up through the OSI model on the receiving side, theoretically what's happening is the application layer on one computer is communicating with the application layer on the other computer. And the presentation layer is communicating with the presentation layer. And the session layer communicates with the session layer, and so on and so forth. Now, I actually have a little animation here to kind of show you what this looks like. So we have a sending computer with some data, right? We just have some raw data here that needs to be sent to the other computer. What happens is that data gets put down to the OSI model, and you'll notice it's going down through the layers, and as it hits each layer, there is a slice of information added to the data. Now, you may have noticed that at the data link layer, there was a slice put not only in the front, but also in the back of the data. It's referred to as this additional header information. And the data link layer also includes one small little piece of trailer information. It has to do with error management. Okay, if there's an error in transmission, it is addressed with that trailer information. But again, I don't want you to worry about that. I just want to explain it because you can see it on the illustration. But what happened is the computer had some raw data. It gave it to the application layer, who passed it on down through the OSI model, and at each layer there was a slice of information that was added. Now, what I wanted you to watch carefully, now we're going to put it out onto the cable, and it travels over to the receiving computer. And what you're going to see here is as it goes up through the OSI model, each layer is going to strip off and acknowledge, basically, the slice of information that the corresponding layer on the sending computer added. Okay, so as it travels up through the OSI model here, you'll see that each layer is taking off the slice of information that the corresponding layer from the other computer added to it. And that's what we mean by that theoretical straight across communication. But in the end, you'll notice that the receiving computer now just has the original raw data that was sent by the sending computer. And that's how data travels through the OSI model. So now you have a pretty good understanding of this one-page cheat sheet where you have to know the 7 layers, you have to know the order of them, you have to know what takes place at each of the layers, you have to know how data travels through the OSI model. But there's one more piece to this one-page cheat sheet, and that is there is some hardware that you need to make sure that you understand and where that hardware functions within the OSI model. And some of this hardware we'll talk about in other lessons. But the main pieces of hardware that I want to talk about, starting at the bottom, there is a hub. Now, a hub is something that we don't really use much anymore. Okay, a hub was nothing more than a wiring box that basically a bunch of computers would plug into, and data would travel into that hub and then would travel out to all other computers. Okay, there'd be no filtering of any kind. It was nothing more than a wiring box that would just spread communication. And the fact that there is no other sophistication to it kind of goes along with what we've described as being the physical layer. It's all about hardware. There's no translation of any kind. There's no filtering of any kind, no routing, no networking. It's just connectivity. That's all that's happening. Same thing with a repeater. A repeater is another device that we don't really use much anymore, but this is a device that you add to a network to extend the distance that a data packet can travel on a cable. Okay, and the repeater doesn't do any kind of filtering or anything. All it does is it receives a packet and it says, oh, I've received this packet and I'm going to, it came in one side and I'm going to send it out the other side and just continue it on down the cable. But if we go up a layer to the data link layer, this is where bridges and switches function. And a switch is what has pretty much replaced the hub. And the reason is because a switch has the ability to filter traffic. It's still a box, just like the hub was, but it can filter traffic based upon something called a MAC address. Now again, there's so many things that I could throw in here, and I don't want to confuse you and get too far ahead, but there's something called a MAC address. And the data link layer, I can tell you, is technically divided into 2 sub-layers called LLC for logical link control and MAC for media access control, or MAC, thus the name MAC address. Okay, and that filtering that's done by a bridge or a switch with the MAC addresses, well, that's done at the data link layer. A router has much more sophistication than a bridge or a switch in the sense that it can have very complex routing tables and can use something called an IP address to really see how to navigate a packet from one place to another through different networks. And that all takes place at the network layer where we have addressing and routing. And the last device I've listed here is actually something I mentioned very early in this lesson, and that's called a gateway. A gateway, I have it listed here as way up at the application layer, but the reality is that gateways can have functionality at any and all of the 7 layers of the OSI model. And the reason why is because a gateway, by definition, by real generic definition, is a protocol translator. And depending on what protocol we're talking about, that protocol might have functionality at some different layer of the OSI model, and therefore the gateway will function at that layer as well. But most gateways typically function at the real high layers in the OSI model. Now again, I'm going to tell you, there's a lot more to know. If you've ever taken any kind of a networking course and learned about the OSI model, you know that it's way more complex than what I'm showing you here. What I'm trying to do is I'm trying to simplify something that is what many people feel one of the most confusing aspects of computer networking. And in order for you to find this simple, you have to allow yourself to. Okay, so if you're right now trying to focus on saying, wow, am I confused? That's a lot going on here. And what does he really mean by network APIs? He only gave me a generic explanation. Or formatting. He said formatting the data. What does that mean? You need to allow yourself to keep this simple. Don't worry about knowing this in more detail right now, because you don't need to. As a matter of fact, there are many very successful networking engineers. Now, I'm not talking about somebody who actually designs networking components, but I mean network engineers where they design networks. They set up networks for big companies who don't know the OSI model any more than the way I've explained it to you right now. Okay, so please allow yourself to take this in as generically as I've given it to you. And with this, what you see on the screen before you, what I used to always refer to as the one-page cheat sheet to anything and everything you need to know about the OSI model on your certification exam, or to get a basic networking job. Just take it in and say, that's it. I'm going to let it go at that. And I promise you, you will be successful.